Mendeleev was the first one to develop the modern periodic table. We talked about him briefly in the chapter 1. He thought that the elements had properties which had patterns to them, and he was correct. He thought it was better to have the functions of their atomic weights, like their masses. And so the first version of Mendeleev's periodic table was based more on mass. Later on, though, scientists figured out, and that's what we're using right now, that it's better to use a periodic table based on atomic numbers. You see the period properties, which we'll talk more later, better through the atomic number than through the mass number. But Mendeleev was cool. He figured out a whole bunch of new elements before they'd been found. So Mendeleev was seen as a pretty cool way. So the periodic table has changed over time. Periods on the periodic table go left to right. So in this animation, the red represents a period. The first period is hydrogen and helium. The second period is lithium on the left through neon. Third is Na, sodium through argon. Fourth is potassium, K through krypton, etc., etc. Notice on this periodic table, hydrogen is listed both on the left and the right. Sometimes hydrogen acts more like an atom on the left in group 1A, and sometimes it acts more like it is right here on the right. We'll talk about this more later, but just realize hydrogen is kind of flexible. Now, I mentioned group earlier. Periods go left to right. Groups go top to bottom. Groups are going to be really important to us. And the way that this animation is set up, it lists the common designation for groups. Groups 1A and 2A are on the left. And you can see on the right, we have groups 7A through 8A. All the A groups are called the main group metals and nonmetals. The elements in the groups in the middle all have B's by them. Those are called the transition metals, or the lanthanides and actinides. They have a different kind of reactivity than the A groups do, and that's what we'll see. So the A groups are main group elements, main group metals and main group nonmetals. The B groups are the transition metals. Oh, there's also some rejected elements in the periodic tables. Bear with me. Some of these are just totally silly and stuff like that. Here's Clorox, which I won't make any jokes about. Asparagus, which I actually like and stuff. You can see that some of them are criminal elements. Some of them are owned by Microsoft. All right, stupid. Just joking. Anyway, sorry. Maybe I'm not sorry. I don't know. Anyway, periodic table then again. So you got the A groups and the B groups like we talked about. Underneath is a set of lanthanide and actinides. Depends on your periodic table again. Lanthanides are usually like 58 or so to 71, and the actinides, depending on your periodic table, 89 through 103, depends on your periodic table once again. But they're just different types of metals, different types of elements. Now, most of the periodic table, like we said in chapter 1, is metals. Everything to the left of the green line is a metal, with the exception of hydrogen in the upper left corner. The yellow ones in the upper right and hydrogen are the nonmetals, and there are a series of elements in the middle, the green in this one, that are called metalloids. They have some properties of metals, some properties of nonmetals, and we'll see in the future sections what it means to be a metal and a nonmetal more. We'll talk about some of these more than others, but I want you to hear these names so you're starting to get familiar with them. Some of the groups have important names. Alkali metals is group 1A. And again, we're going to use the A groups in this class a lot, but there is another alternative designation you can see in this periodic table. Group 1A is also group 1. I call the number systems the international version of the periodic table. It's the same thing, but the 1A, 2A, 8A has a lot of use for us, so we're going to use that predominantly. Anyway, group 1A or group 1, they're the alkali metals. And right next door, group 2A or group 2 are the alkaline earth metals. And those are different groups, and they're both important, and they're both going to pop in. So remember, group 1A, alkali, group 2A, alkaline earth. Now, there's several groups that have kind of cool names, but we won't use them that often. Group 3A, the fancy name is icosanogens, but I'm going to call them once in a while twisted metals. And I'll explain in later lectures why I call them that way. That's an unofficial name. It's something you have to use, but there is some reason why group 3A is kind of twisted. Group 4A is a real mixture of nonmetals and metals, like carbon on the top and lead on the bottom. So you got some really wild properties. properties. Crystallogens is their fancy name, but again, nobody uses that except nerdy instructors like me. Group 5A, pnictogens, another name nobody hardly used. That apparently has something to do with to choke. Phosphorus, arsenic, stuff like that, bad news. Group 5A. Chalcogens, chalk formers, are in group 6A. Again, that's an informal name too. Oxygen, sulfur, selenium, etc. Now, another one I do want you to know, halogens. Halogens is group 7A. That's chlorine, bromine, iodine, fluorine. Very important. And the noble gases in group 8A are also important too. Those are on the far right. So please know alkali metals, alkaline earth metals, halogens, and noble gases, but the rest of them you can totally ignore. So, which list of elements contains an alkali metal, a pnictogen, and a halogen? Alkali metal, group 1A, pnictogen, group 5A, halogen, group 7A. And I'll let you explore this one on your own, but if you look at that list long enough, it's answer E. Rubidium is an alkali metal, group 1A at the bottom. Antimony, we talked about earlier, is a group 5A pnictogen, and astatine is a radioactive halogen.